Welcome, this is Mrs. Rubright with Algebra 1 Honors, and today we're doing 1.7, solving absolute value equations. This first example wants us to solve by graphing, and they want us to use a graphing calculator. However, since you guys don't have graphing calculators, we're just going to do this manually. So how you would solve this equation is you need to get the absolute value bars by themselves, isolated. So I need to subtract 1 from both sides. That would leave me with 2 absolute value x minus 3 equals 4. Divide by 2 on both sides. You would have the absolute value of x minus 3 equals 2. Once the absolute value bars are isolated, you are going to set it equal to the positive and negative versions. So you drop the absolute value bars, and you set it equal to the positive and negative versions of the other side. So you have like two equations. And then you just solve these one-step equations. So x equals 5, and x equals 1. Well, let's think about this. If I plug in a 5 minus 3 is 2. The absolute value of 2 is 2. 2 times 2 is 4. 4 plus 1 is 5. So that works. Let's plug in a 1. 1 minus 3 is negative 2. The absolute value of negative 2 is positive 2. 2 times 2 is 4. 4 plus 1 is 5. So it works. Because basically all you want is this to give you 2, right? Because 2 times 2 is 4 plus 1 is 5. This is kind of, if you think about this, as like 2x plus 1 equals 5. Like if we just said that the whole absolute value part was just x. Minus 1, minus 1. 2x equals 4. So x has to equal 2. This absolute value portion has to equal 2. So it really has to equal 2 or negative 2, because the absolute value of negative 2 is 2. That's why you have two answers. Does that make sense? All right, so why is the y-coordinate of both points of intersection equal to 5? So let's graph this thing. All right, so we know that x equals 5 and 1. Okay, so if we plugged in, say, 3. 3 minus 3 is 0. The absolute value of 0 is 0. 0 times 2 is 0. 0 plus 1 is 1. And then if we had to move, okay, so, sorry, let's go back. So this is your y equals, right? If you solved it for y equals. So I plugged in as, what was I saying? 3. 3 minus 3 is 0. 0 times 2 is 0. 0 plus 1 is 1. So at 3, it should be at 1. If I plugged in a 1, 1 minus 3 is negative 2. Negative 2 is, the absolute value of negative 2 is 2. 2 times 2 is 4. 4 plus 1 is 5. So when I plugged in a 1, I should get 5. If I plug in a 5, that's 2. 2 times 2 is 4. 4 plus 1 is 5. So 5, 5. So this is what it should look like. Does that make sense? Do you guys remember graphing absolute values ever? Have you ever done that yet? No. They're V's. It'll always be a V. We actually have rules in terms of, did you guys ever learn any of the rules with like shifting left, right, up, down, down? So technically in here, you shift left or right opposite of what you think. So you're shifting in the positive direction 3, which is to the right 3, and up 1. So if I did the absolute value of x, it would be at 0, 0 with a v going like this perfectly. But this is shifted in the positive direction 3, up 1, which I can see from right here. Positive direction 3, up 1. Just a cool little fast trick. And it shows you where that vertex should be. Isn't that kind of cool? Positive direction 3, up 1, over 3, up 1. That's where it starts. Obviously, you can still do plug and chug and stuff, but isn't that kind of neat? All right. Why is the y-coordinate of both points of intersection equal to 5? The y-coordinate anyone? Didn't they give us a second equation? Let's see. Enter the first equation and the second equation. Their second equation is y equals 5. So they're asking if I drew the line y equals 5, which is right here, right? Everywhere on this line, y equals 5. And then this one is y equals 2, absolute value x minus 3 plus 1. So I have these two lines. Why are both of the intersections at y values of 5? Because y equals 5, every single y value is 5 on that line. So that's why they would intersect there. Because y equals 5 only has y values of 5. The vertex of the absolute value graph is the lowest point if the graph opens upward, or the highest point if the graph opens downward. The vertex of the graph of y equals 2 times the absolute value of x minus 3 plus 1 is 1, 3. Our vertex no, it's not. Is that a different problem? How are the coordinates of the vertex related to the equation? It says that the vertex of the graph is 1, 3, but it's not. It's at 3, 1. They have a typo. This is a typo. The vertex is at 3, 1. Typo. Okay, they have a typo. Our vertex is clearly at 1, 2, 3, 1. Okay? How are the coordinates of the vertex related to the equation? So they're related because it's the opposite here, and then it's the same there, right? The x-coordinate is the opposite of the number inside the absolute value bars. And the y-coordinate is equal to the number added to the absolute value. So like I said, this shift is left-right, opposite of what you think. Up, down, right? Shifting vertically. So this is up 1. Solve the equation using algebra. Okay, so we're going to subtract 1 from both sides, which leaves us with 2 times the absolute value of x minus 3 equals, oh, they want us to show the minus 1, my bad. So minus 1, that gives us 4. Then we're going to divide by 2 on both sides, which leaves us with it equaling 2. Then we set up our two separate equations. So x minus 3 equals 2 and x minus 3 equals negative 2. So interpret the equation. What numbers have an absolute value equal to 2? So 2 and negative 2 both equal 2, right? That's why. So we want to set what's in there equal to 2 and equal to negative 2. So we're going to add 3 to both sides, and x equals 5. We're going to add 3 to both sides, x equals 1. That's the algebraic way. The left side of the equation, equivalent to this expression for each solution of the equation. Evaluate this expression for each solution of the equation. Okay. So 2, 5 minus 3, plus 1. 5 minus 3 is 2. The absolute value of 2 is 2. 2 times 2 is 4. And 4 plus 1 is 5. 2, 1 minus 3. 1 minus 3 is negative 2. Absolute value of negative 2 is 2. And 4 plus 1 is 5. It helps you verify that, yes, you solved it correctly, right? When you plug in and just double check. Have you guys solved absolute value equations before, or is this the first time? You've done it, yes? Suppose the number on the right side of the equation was negative 5 instead of 5. What solutions would the equations have? Why? When answering these questions, you may want to refer to the graph. Okay. So they want it to be equal to negative 5 instead of 5. So you'd subtract 1. Divide by 2. Your absolute value would have to be equal to negative 3. Can you have the absolute value of something equaling a negative number? Can the absolute value of something equal a negative number? Absolute value is the distance a number is from 0. Distance can never be negative. So, no solution. That would have no solution. Make sense? Absolute value can never equal a negative. It can never equal a negative. Okay. Sal exercises by running east 3 miles along a road in front of his home and then reversing his direction to return home. He runs at a constant speed of 0.1 miles per minute. Write and graph an absolute value equation that gives the distance d in miles from home in terms of the elapsed time t in minutes. Use the graph to find the times at which Sal is 1 mile from home. Determine the 3 key values of the distance equation. When Sal begins his run, t equals 0 minutes, he is 0 miles from home. So d equals 0, right? When Sal reverses directions, he is how many miles from home? He's running east 3 miles along the road in front of his house and then reversing his direction home. So how far away from home is he when he turns directions? 3 miles. He reaches this point in t equals 0.01 miles per minute. So how many miles out of that? So 3 miles out of 0.1 miles per minute. So how many minutes? What is 3 divided by 0.1? 30 minutes. So when t equals 30, his distance is 3 miles. When Sal returns home, he is blank miles from home. 0 miles from home, right? Because he has ran a total of 6 miles, he reaches this point in t equals 6 miles at a 0.1 miles per minute. It's going to take him 60 minutes, right? So when t equals 60, his distance is 6 miles. Actually, no, it's not, sorry. His distance is 0, right? Trick question. Because the distance is how far he is from home. Makes sense? Because he turned around and came back home. That is a trick. All right. Add axis labels and scales to coordinate plane. Then plot the points TD using time and distance values in part A. The equation is the absolute value equation, and the vertex of the equation's graph is the point that represents when Sal reverses directions. Draw and complete the graph, and then write the absolute value equation. Okay, so we have t is 30, d is 3. So 33. $60, 0. He also had 0, 0. You guys see it? So it normally would be 0, 0, but it's been shifted 30 to the right, opposite of what you think, right? And it was shifted up how many? 3. This is right 30, up 3. To find the time when Sal is 1 mile from home, draw the graph y equals 1. Well, this is 3, this is 4, so this is 2, this is 1. So his distance is 1 here. To find the times where he's 1 mile from home, he's 1 mile from home here and here. Well, let's look. 5, 10, 15, 20, 25, 30, right? These are going by 5s. 35, 40, 45, 50, 55, 60. So, at 10 minutes and at 50 minutes, he's a mile from home. Show how to use algebra to find the times when Sal is 1 mile from home. So using algebra, we would put in d equals 1. Substitute d equals 1. Hold on one moment. Hello?
He is not on, like, he has a nice dinner day, and so they think that he's not playing that. Okay? You're welcome, bye.
Alright, so show how to use algebra to find the times when Sal is 1 mile from home. So you're going to substitute in d equals 1. So you're subbing in here. So you're going to do 1 equals negative 0.1, absolute value t minus 30, absolute value plus 3. Alright, so you're going to subtract 3 from both sides. Negative 2 equals negative 0.1, absolute value t minus 30, absolute value. You want the t by itself, so we're going to divide out the negative 0.1 on both sides. We're going to have the absolute value of t minus 30 equals 2 divided by 0.1. What is negative 2 divided by negative 0.1? What do you guys get? Anybody? What?
Negative 20.
A negative divided by negative is a positive.
Oh,
Positive 20.
Yeah.
So, now we have our two equations. T minus 30 equals 20, and t minus 30 equals negative 20. Right? You set it equal to, drop the absolute value bars, set it equal to the positive, negative versions. Add 30 to both sides. T equals 50. Add 30 to both sides. 30 plus negative 20 is 10. So t equals 50 and t equals 10. Same answer. But this way we solved it algebraically instead of graphically. Okay, so next we are going to subtract 4 from both sides. Well, actually, let's not. All right, so this is how we're going to do it. What is my shift? Negative direction or left, 1, up, 4. So, left 1, up 1, 2, 3, 4. Here's my vertex, right? Then I'm just going to do a nice little XY table. I'm going to go 2 to the left, 2 to the right. Negative 2, negative 3, 0, and 1, right? If I plug in a 0, 0 plus 1 is 1. The absolute value of 1 is 1. 1 times negative 2 is negative 2. Negative 2 plus, oh, what do I have to do first? What did I just do that was wrong? What did I just mess up? It has to be set equal to, what does it have to be set equal to first before I can do anything? Y, or 0, right? So I had to add 4 to both sides first. So this really should have been negative 2, absolute value of x plus 1 plus 8 equals y, or equals 0. Right? You have to set it equal to y, or 0 first. So it's really up 8. That's my vertex. You guys get that? So now, if I plug in a 0, absolute value of 1 is 1. 1 times negative 2 is negative 2. Negative 2 plus 8 is 6. So your y is 6. So at 0, you get 6. At negative 2, I should get the same thing. So let's see. Negative 2 plus 1 is negative 1. 1 times negative 2 is negative 2. Negative 2 plus 8 is 6. That nice mirroring that I should be getting. If I plug in a 1, 1 plus 1 is 2. Absolute value of 2 is 2. 2 times negative 2 is negative 4. Negative 4 plus 8 is 4. For negative 3, I better get the same thing. Let's see. Negative 3 plus 1 is negative 2. The absolute value of negative 2 is 2. 2 times negative 2 is negative 4. Negative 4 plus 8 is 4. And now we have our absolute value graph. So look, it's down 2 over 1, 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 down 2 over 1. So my solutions, my x-intercepts, are 1, 2, 3, and -1, -2, -3, -4, -5. Let's see if these work. 3 plus 1 is 4. 4 times -2 is -8. -8 plus 8 is 0. Right? Is this making sense? Are you guys understanding this? Are you guys getting it? That's a graphing one. Let's try an absolute value using algebra. Get the absolute value bars by itself by getting rid of whatever's on the same side that's not attached to it first, using opposite operations. 12 equals 4 times the absolute value of x plus 3. Divide by 4 on both sides. The absolute value of x plus 3 equals 3. So you're going to have x plus 3 equals 3, and x plus 3 equals -3. Subtract 3. X equals 0, and x equals -6. You're going to get 0 and -6 as your solutions. So when your absolute value bar graph is going downward, right? And we know it's going downward because of this leading coefficient in front of the absolute value bars is negative, so we know it's going down. This one's going up. This one has an imaginary 1, so it's going up. Make sense? If it's going down, this is a maximum. Right? A maximum. When it goes up, your vertex is a minimum. All right, so the number of gallons of water in a storage tank is given by this. It's already solved for y, so that's nice. Where h is the time in hours since the tank was last emptied. What is the maximum number of gallons that the tank can hold? So for the maximum number of gallons, think about graphs are always y and x, right? So we have our y. What is our x? Our x is an h. And the number of gallons is given by this. This means that this is your gallons and this is your hours, right? Gallons and hours. So we want to know the y-coordinate of our vertex, right? Isn't that what we're looking for, the y-coordinate of our vertex? Well, where's our vertex going to be? Opposite of this. It's going to be at 20 and up to 800. And it's going down. Just a rough little sketch, right? It's going to look something like that because we're going in the positive direction 20, up 800. So what is my maximum gallons? 800.
Sorry, I'm having trouble with the connection. Please try again in a moment.
Your phone shouldn't be out, whoever that is. For what values of H is the tank half empty? So what value of H, if it's half empty, it would be at 400 gallons. So plug in 400 for your gallons. All right, so 400 equals -40, absolute value, H minus 20, absolute value, plus 800. Subtract 800. -400 equals -40, absolute value, H minus 20, absolute value. Divide by -40. H minus 20, the absolute value of that equals 40 divided by 4. How many times does 4 go to 40? 10 times, right? Negative divided by negative is a positive. So we're going to have h minus 20 equals 10, and h minus 20 equals negative 10, plus 20. H equals 30, or h equals 10. That's going to be 30 hours and 10 hours. For what values of h is the tank empty? So now we would set it equal to 0. 0 equals negative 40, h minus 20 plus 800. Negative 800 equals negative 40, h minus 20. Divide by negative 40. 20 equals h minus 20. Negative 20 equals h minus 20. So you're going to get 40 and 0. If the tank is empty, how long does it take to refill it? Okay, so if it's empty, starts empty, how long does it take to get to that 800 gallons? That's your vertex. 20. 20 hours. Is this making sense, guys? Are you understanding it? Good. The number of shoppers in a store is modeled by this, where T is time in minutes since the store has opened at 10 a.m. For what values of T are there 100 shoppers in the store? So 100 shoppers equals negative 0.5 T minus 288 plus 144. Subtract 144. Negative 44 equals negative 0.05 T minus 288 divided by negative 0.05. When you do that, what is 44 divided by negative 0.05? Is it 88? Anyone with a calculator? 88, right? So now you're going to have T minus 288 equals 88. T minus 288 equals negative 88 plus 288. What is 288 plus 88? So it's going to be 200 and 376. What times are there 100 shoppers in the store? So this is 200 minutes after 10 a.m. What is 200 minutes after 10 a.m.? Well, there's 60 minutes in an hour, right? 6, 12, 18. So 180 is 3 hours. So this is 3 hours and 20 minutes. So 10 to 11, 11 to 12, 12 to 1, 120. And 376. What's 376 divided by 60? Think about it. What's 376 divided by 60? So over 6 hours. So 6 hours would be 6 times 60 is 36. So 360 minutes is 6 hours. So this is 6 hours and 16 minutes after 10 a.m. 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, 3 to 4. It's going to be 4:16 p.m. What is the greatest number of shoppers in the store? Well, let's look at this. This is downward. Where's my vertex? I'm shifting in the right 288, and I'm going up 144. So your shoppers is your y, your time is this. So this is your y is shoppers. So the highest number of shoppers is 144. What time does that happen? It's the vertex. 144 is at 288. What is 288? 288 divided by 60. Well, 60 times 4 hours would be 6, 6, 12, 12, 12, 24. 240 minutes, right? 240 minutes is going to be 4 hours. And then that's 48 more minutes. So 4 hours and 48 minutes. So 10 to 11, 11 to 12, 12 to 1, 1 to 2, 248. Make sense? Is this annoying? Yes. Is it impossible? No. So your homework tonight is page 45 and 46, as well as your review for your quiz on 1-1 to 1-7. That review I'm going to post the answers right here so that you guys have them. You can pause this video, and then you will have these answers on your review. Your review is page 61, 9 through 31 odd. So here are the answers. Let me zoom it in a little bit. I can also post this on Edmodo probably. But just so it's in this video, which will be posted on YouTube, here are the answers to tonight's review for your quiz on 1-1 to 1-7. Have a great night.